we move into talking about special patterns of blood stains. These are 6 patterns that we want to specifically know. So we have gunshot spatter, impact spatter, cast-off spatter, arterial spray spatter, expirated blood, and skeletonization. Let's go through them one at a time. We begin with the gunshot spatter. And again, we're talking about these very fine forward spatter. Forward spatter means, remember, going away from the source being the gun. So the gun hits the victim and often travels through them, and you get some very fine forward spatter. And that would be from the exit wound, obviously, because there's a thickness to the person. And then back spatter from the entrance wound. So we would see the different, if I could identify which was back and which was forward, I can now tell which side the bullet entered from, where did it exit. But if the bullet does not exit the body, then I only have that back spatter. So then that's going to tell me something about that. So I can look for, do I have both? Do I just have one? Sometimes you end up getting some back spatter affecting hitting the gunman. That's called the drawback effect. And sometimes it actually goes, if the gun is particularly close, sometimes it can actually, the blood can go back into the gun, the rightful area of it. Cast-off spatter is this when something is being repetitively hit as the object, so if I'm going, the easiest thing is that you see in the picture is a club. So if a club is hitting a person and to the point where they're bleeding, when they hit, the club gets covered in blood. And then when they pull it back for a second hit, as they pull it back, it's going to spatter backwards on the wall. And then as they hit again. So by counting the individual sets of these cast-off spatters, they can get an indication of how many impacts there were. And that can kind of tell them something about the scene. Arterial spray is when an artery of a person is cut. So the artery is where the blood is flowing through our bodies. And highly oxygenated blood is moving through the body. And when we see that, when it gets cut, so every time the heart pumps, it pushes out from the artery. And so you tend to see these sprays, and it's a little bit like the cast-off spray in that you see these kind of like spurt, spurt, spurt. However, the pattern is different than cast-off because it's coming from a wound. So this can sometimes, and the original injury can sort of sometimes tell you where they were hit from this. So we could see, especially if we're on the scene fairly soon before, we can see that it's bright red because it was highly oxygenated. Also, you can kind of see that you have like several different patterns here. And so this might be helping tell the movement of the person, especially if they didn't die immediately and they moved, you can start to see how they moved, again, reconstruct to back, how were they positioned when they were initially hit. Then we have expirated. Expirated means it's basically got bubbles in it, air bubbles in it, because it came from a part of the respiratory tract. So if it came out from the mouth or the nose, we'll have oxygen in it. So there'll be like little bubbles in it. And blood dries up fairly quickly. That's in the next section, the skeletonized. And so what you see is like the bubble kind of gets stuck in there. You can kind of see the remnants of the bubble. You can see over here where you see kind of like air bubbles kind of stuck in these patterns. That's telling us that this probably came from a path where there was air. So this would be from the airway, the lungs, from the nose, the mouth, and that tells us a source of where the injury in the person was. Also, because they have a lot of oxygen and in it, they tend to be a lighter color, bright red versus a little bit darker in red. And that sometimes can tell you something. So we just need to know that expirated means it's got those bubbles in it, and that tells us something about the nature of the injury. Skeletonization is the idea that it doesn't take very long for blood to start to dry, but it's going to dry at the outside of the droplet first, and then eventually dry all the way to the inside. So kind of like paint. You know, the edges are going to dry first and the middle is not going to. So when the edges are dried, but the inside has not dried, that's this phenomenon of what we call skeletonization. That skeleton on the outside, as it hardens, kind of keeps the shape of the drop. Even if the blood is wiped, you may still have the skeleton perimeter showing to see that there was blood there. So this usually occurs within a minute of the blood drop. So you can sometimes see that there, especially if somebody was moved, and like they tried to clean up the blood but they didn't do a good job. You can still see that skeleton there, meaning that there had been blood there and it was tried. There was an attempt to clean it up. And sometimes if you can tell the extent of skeletonization, they can determine the timing of how long it was there, but that's on the sketchy side.